Hi, so let's look at the most interesting question in this set. This question is interesting at a lot of levels. Let's look at those, so brace yourselves. You're dividing a number by 11, 13, and 15 at different times, right? So it's not successive. When you divide by 11, the remainder is 2. When you divide by 13, the remainder is 6. And when you divide by 15, the remainder is 10. Now, the question would have been very easy if it asked you for the number itself. Then you just substitute from the options and there quickly you solve the problem. But the question is asking you for the sum of the digits, which means that you have to actually sit and find the number without any help. And what makes it more complicated is that the difference from the number is not the same. Let's see what I mean by that. Typically, when remainders are different, they have the same negative remainder from the original question, from the original number. So let's say you're dividing by 3 and you want the remainder to be 2, and you're dividing by 4 and you want the remainder to be 3. Now the remainders 2 and 3 are different, but if you see that it is a negative remainder of 1 from 3 and a negative remainder of 4 of 1 again from 4, then you can see that the two remainders are the same, right? But in this case, that's not happening. 11, 13, 13 and 15, they're all differing by 2, whereas the remainders are differing, right, by 4. So 2 to 6, the difference is 4, and 6 to 10, the difference is 4. But since the differences are same, we can still use this to get the answer very quickly, right? So let's solve this step by step. First step, we will need to find the LCM because you have to remove the negative remainder from the LCM, right? So what is the LCM of 11, 13 and 15? They are all relatively prime from each other. So the product can be found by just multiplying the three numbers. So 11 into 13 is 143, 143 into 15. So 140 into 15 is 2100 and this will be 2145. Right, that was easy. Right, okay. Now 2145 will leave remainder 0 with respect to 11, 13 and 15. Right, let's subtract 5. So you're looking at negative remainder 5 now, which means you are at least satisfying remainder of 10 with respect to 15. Okay. Right. Now 2140 is negative remainder 5 from all the three numbers, which means that from 15 it will leave remainder 10. If I divide by 13, negative 5, it will leave remainder 8. And if I divide by 11, negative 5, it will leave remainder 6. But do I want 8 and 6? No. I want 6 and 2. At the same time, I don't want this remainder to change, which means I can subtract as many 15s, right? As long as I keep subtracting 15 from 2140, the remainder with respect to 15 is not going to change, right? And if I subtract one more 15, then I'm subtracting, what is 15? 15 is 13 plus 2. So when I subtract a 15, I'm subtracting a 13 and an extra 2. So the remainder with respect to 13 is going to drop to 6. And straight away the remainder with respect to 11 is going to drop to 2 because 15 is 11 plus 4, right? I hope this can be understood. If not, give it some thought. I'm sure you'll get it, right? What will we do? We will subtract 15 from 2140 to get 2125, right? And this number, if you check, will leave remainders 10 with respect to 15, 6 with respect to 13 and 11, 2 with respect to 11. So this is your answer, 2125. And the sum of the digits of this number is 10, so your answer is option 4. Right? Let me just go through the whole thing again. What are we doing? We are trying to find a number that leaves these different remainders, 2, 6 and 10 when you divide by 11, 13 and 15 independently. Right? Now, the negative remainders are also different, but as I've told you, the differences are the same, which means that we'll first find the LCM of all the three, which is 2145. And I want the condition of 10 remainder with respect to 15 to be satisfied. So I subtract 5 and I get 2140, right? Now 2140 itself leaves these remainders: 10 with respect to 15, 8 with respect to 13, 6 with respect to 11. To change it, to drop 8 by a 2 and to drop 6 by a 4, I need to subtract a 15, right? And that is going to be our answer for the number. You have to do one more step, find the sum of the digits, and the answer is 10. Hey, it was great talking to you. This ends your second day. I'm going to go and listen to some music. You have a good day.